CIPT, Cyber Intellectual Property Theft. The same equations that we used in cyber identity theft can also be used in cyber intellectual property theft. Let us state here that we are focusing on just the music industry. The music industry is the dominant industry that is affected by this particular problem, and they also have the most data available. But let's just take a look at what we're dealing with here. On the defender side, we have an annualized loss expectancy of $20 billion per year. That comes from the Recording Industry Association of America, RIAA. This is all for the United States, by the way. Exposure factor we assume to be 100% in all cases. The annualized rate of occurrence, which would be the number of downloads of music, is estimated by RIAA as 20 billion a year also. Using this calculation, ALE equals AV times EF times ARO, we can compute that the asset value is $1 per per asset. And this is confirmed by common retail music sources that show that you can download a music song for 99 cents or so. So cyber intellectual property theft is a $20 billion problem, according to these figures. At 300 million people in the United States, it's a problem of a proportion of about $67 per person per year. Now this also means, since there's 20 billion downloads occurring and 300 million people, that every single person in the United States of America is downloading 67 songs per year. The attacker is an interesting question. The attacker, of course, gains the $1, and the probability of getting caught, if we compute it using copyright data from the Department of Justice, the number of cases that were listed there, even the ones that were not where they won. Basically, there were 2,084 copyright cases of music and other things in, I think it was 2005. So before the RIA became really active, but basically 2,084 cases, and there were 20 billion incidents. So 2,000 divided by 20 billion is basically 1 out of 10 million. So your probability of getting caught is basically 1 out of 10 million. Using the equation that I developed, the annualized gain expectancy is the asset value minus the annualized cost of attack. Now, on a per incident basis, if the cost of getting caught is less than is less than $10 million, then attack. This should say 1 times $10 million here, but basically it's if the cost is, if you'd be willing to go to jail for $10 million, go ahead and attack. Now the question is, what's the economic feasibility of this type of security? It's probably every single person watching this video knows somebody that has downloaded a song illegally. If that's the case, who's the enemy and who's the defender? Obviously the RIAA and the music industry is a defender, but what's the proper technical way of solving this problem? Looking at this analysis here, we can show that it's 66, 67 again per person, and here we can show that if you are willing to go to jail for $10 million, it's probably worth downloading songs. But some of the things people may not realize is the song Happy Birthday is copyrighted. If you've ever sung it, you're guilty of infringement. The enemy is basically not the same thing as conventional bootleggers before the days of the internet. Whitney Harper was nailed with a $27,000 fine for illegally downloading songs when she was 14 to 16 years old, and she was actually originally ordered to pay $7,400, and then the state Supreme Court raised it to $27,750. Joel Tenenbaum was nailed for $675,000 as a jury verdict. The judge reduced the verdict to $67,500. Then an appeals court reinstated the original $675,000. Another, Jamie Thomas Rassett, family there was prosecuted and ordered to pay $1.5 million for sharing 24 songs. And it's a widely publicized case. You can see the information in a video on Hulu.com called RIP, a Remix Manifesto. They're in there. But these are the enemies. So the question is, who really is the enemy, and what's the net benefit of defending against this particular type of attack? Next, we will talk about distributed denial of service attacks.